Okay, where are your notes? We're starting. Okay?
Took the first part today and I'll do the second part tomorrow.
Okay. Now,
4.1 day 2. We're on 4.2 day 2.
day 2. On Friday, we did the mean value theorem. Yeah, you need to do your homework. Okay. Today, we're going to work on increasing and decreasing functions. How do we use the derivative to find those? And what are your local extreme values? Not what are they, but where do they occur? Okay, you guys? Shh. Grant, how would I know if a function is increasing? Well, what does an increasing function look like? What's positive? Can't use it. Because, why? Because there's an increasing function, and there's an increasing. The second one is increasing at a slower and slower rate. Right. So, what has to be true about the derivative? This is as hard as it is today. The derivative must be positive. Sorry. So if I draw, I don't necessarily memorize it. I might draw a little sketch because I know what increasing and decreasing is. So f prime must be greater than 0. When you are on the exam, you're going to have to make that statement. This is your justification on the free response. We're going to do some sign charts, but that's not good enough. You have to say the first derivative is positive. It's how you get your points. Okay, what about a decreasing function? Well, let's draw a decreasing one. Like this, and like that. And what's true about the slopes of a decreasing function? They're negative. Function's not negative, the slopes are. The function could be negative. So f prime is less than 0. Again, that's your justification on the exam. How do you know if a function has an extreme value? Where do we look to find the extreme values? Now these would be endpoints if it's a closed interval, but that would be, we're talking about local ones, so we're talking about in the interior. So there is one of them. There's another one. So f prime is equal to 0. That's a candidate. That doesn't guarantee it. And then we have this. What's true about the derivative at these corners? Generally speaking, but not always, the derivative not existing usually means a sharp corner. Now, what has to be true? I can give you a function here that has a slope of 0 right here. It has a horizontal tangent. Does it have an extreme value there? No, even though f prime equals 0. What's true about the slopes here? What's the slope about this? It's always what? Okay, it never changes sign. So what has to be true? I should say f prime never changes sign. So what has to be true to guarantee that I'm going to have an extreme value? I'm not saying what kind I have, but the sign changes on the derivative. F prime, and you have to make that statement. You can't just say it's negative or it's positive. You have to say the sign changes. F prime changes sign. No, I want to say must change sign. There we go. And then we just have a couple little examples. To have an extreme value. And we'll talk about, now that's a preview of 4.3. And we'll talk about, if it goes from positive to negative, negative to positive, we will talk about what whether or not it's a max or min. I always draw the pictures. I don't memorize it. Those, some of you may want to. Okay? And this has a negative slope here and a positive slope, and that's undefined at that corner. That's really all there is. So the questions are going to ask you, like the next page. Given these functions, find where the function's increasing and where the function's decreasing. It is not a closed interval. So we're not going to look for absolute max mins. I'd have to graph it. Okay, so Grant, what am I going to have to do here? Find the derivative. So let's find the derivative. F prime of x is equal to what? 6x squared
Plus
6x minus 72. And that, is that ever undefined? No. It's a polynomial. It's easy. Nothing fancy there. So I want to find out where this is 0. Because I have to find out where it's 0 so I know where it changes from increasing to decreasing the function. Okay? So if I factor out what? 6. No. 6x squared plus what? X minus 6 goes into 72, 12. Does that factor? Does that factor? Yeah. X and X plus and minus, what's going to go here? 4 and 3. Okay, so you should be taking notes on this. So I'm looking at 0 product property. That's 0, or x minus 3 is 0. And I'm going to do a little line graph. And this is going to be, these are the zeros of my function, of my derivative function. What is the shape of that function? It's a parabola, right? So these would be the zeros of that parabola. This is x equals 3. This is x equals negative 4. So don't put that in the wrong place. So this is negative 4, and this is 3. And I always mark my graph. I always say it's 0. Because if the derivative is 0, you know the function's going to be nice and smooth. Now, I'm going to draw a picture of the derivative graph. Because I really just want to know if it's positive or negative. The derivative is positive or negative. So we know it's a parabola. It looks something like this. So what's true about the derivative? Is this positive or negative here?
negative and positive.
Not its slope. The derivative itself is positive, right? You could test negative 10. Put negative 10 in here. Put negative 10 in there, and this gives you a negative times a negative is a positive. What's the easy number you could test here if you didn't want to do it my way? 0. If I put 0 in here, this is positive. That's negative. So this is negative. Notice that the parabola drops below the axis. I can do it the easy way, which is by picture, if I understand that, or I can just test the regions. And what about over here? The derivative is positive. So where's my function increasing? From negative infinity to negative 4. This tells me a lot. Now, there is no agreement about whether or not we should include these negative 4 and 3. You have to read the context of the problem. I'm not going to. Just because when I do the second derivative test, you never include the endpoints, ever. So we'll just not include them, and that'd be our safest bet. Where else is it increasing? 3 to infinity. And so where is it decreasing then?
Negative 4 to 3.
Negative 4 to 3. Now,
Do we do the boxes at all for like negative 4?
no, that's what I was just talking about. I will always leave them open, and then I won't have any problem. Because we'll be doing second derivatives, we always leave those open. So we'll just leave them all open. Nobody's agreed on the first derivative. So both are correct. That's an or. Union's easier, but... Okay, guys? Just a little preview into tomorrow's. If my function's increasing here and zeroes out and then decreases, is that a max or min? Right here. The function's increasing and then it starts to decrease.
Max.
That's the maximum. So we'll have a first derivative test. But I just draw the picture just like right now. And then it's going to decrease and then it's going to increase. So what do I have here? A minimum. And you know what? That's what the function looks like. It's a cubic. So just by using the derivative, I kind of know what it looks like. I don't know where it is. I don't know exactly how high it is. I don't really care. Okay. So the extreme values occur where?
Negative 4 and trace.
And now they could ask you what the values are. I'm not sure what question was really being asked here. Maybe calligraphy pen. Okay, let's try this one. And maybe you prefer to write this as f of x is equal to e to the negative 1/2 x. Is that better to look at for you? Doesn't matter to me.
Sure.
There's no endpoints. I just want to find any local max or mins. If you think about it, what it looks like, this shouldn't be too hard. What's f prime of x? E to the what? Negative 1/2 x times what? Negative 1/2. And if I simplify that a little bit, I like to put the negative 1/2 in the front. Well, what's true about e to the negative 1/2 x? Does it change sign? Is it ever 0? It's never 0. E to the x is never 0. E to the negative 1/2 x is never 0. Okay, guys? E to the x is never 0. Okay, so what's true about your first derivative? F prime is what? Always what? This is a negative 1/2. This is a positive number. It's always, oops, negative. Which means what's true about my function? If the derivative is negative, f of x is decreasing. Because e to the negative 1/2 x is always positive. In fact, if I knew what that looked like, this is kind of a silly problem really, but e to the negative 1/2 x looks like this. It's always decreasing. Pardon? What? There's no local max or mins, no local extreme base. There are no endpoints either. Where are they? Right, there's no endpoints then. Infinity is not an endpoint. Yeah. And for our class, we're going to keep the local extremes in the interior, not looking at the endpoints for those.
So how would we explain that on the
This is exactly what I wrote. I would take the derivative, say the derivative is always negative, therefore the function's always decreasing. It won't be that simple. So there's no local extreme values. There's no guarantee that there are any. Okay? Only if I have a closed interval can I guarantee both a max and a min. Remember the max-min existence theorem from last week? You can do the locals, there aren't any. If I close this, close it here and here, then this would be the maximum value and this would be the minimum. Okay, Grant, question? Okay. That's it. That's all there is to this section. So that's what you have to do. Grant, I bet I say your name more often on my videos. You guys watch the videos by now.
I watched it and like Chris, stop.
It does make this funny. Okay, that's it.